Yes, Srikant, we are on live.
Okay, thanks. Ma'am, we can start.
Okay, perfect. So we're just to confirm, we're live as well, and then there are people. The people participating over here, are they students or staff?
A few of us are instructors, ma'am. Maybe I will read out the names who are students. Mukesh Kumar Singh
Yes.
and Varun is a student. These two are
Okay.
students.
Okay.
Maybe some students might join a bit later.
Okay. Okay. Sure.
So
Sure.
we can start.
Sure. Okay. Sure.
Yeah.
Let me just to get us acquainted. Let me just share my screen. Okay, so the course that we are going to be starting next semester, starting I guess June semester, will be on statistical computing. Now, one thing is that just by the name of it, it might sound like it's going to be a sort of very heavy coding course, which is sort of true, but not completely true. So what we are going to learn in the course is going to be the statistical concepts behind a lot of the computing algorithms. So just to give you an example, in R or in Python, when we are trying to draw samples from a normal distribution, let's say, or any other distribution, there is something going on under the hood when we run commands like rnorm or runif or numpy.random.normal. And what is actually happening that ensures that we get a random draw from a normal distribution or a uniform distribution or a gamma or a Poisson or so on. What is the mathematics or the statistics that ensures that these are draws from the required distribution? That is something we're going to learn in the course. Of course, we will also do implementation as in what type of, how do you actually implement these algorithms? We're going to focus on R predominantly, but of course you can also try in Python as well, okay? The other thing we'll focus on, so there are roughly 4 parts of the course. The first part is learning how to draw from these distributions. And the second part is something called Monte Carlo and also importance sampling, which is when you have drawn samples from these distributions, these rnorm, unif, uniform, and so on, what can you do with them? Okay, so one of the things we'll focus on is Monte Carlo or importance sampling, where we will use the draws to estimate certain integrals or expectations. So we can think of really complicated integrals that we don't know how to analytically solve. They're not your, class 11th, class 12th integrals, which are easily solvable. So instead, we will try to estimate or approximate them using Monte Carlo or importance sampling technique. So that's the second part of the course. Then the third part of the course is our numerical optimization techniques, or in general, or specifically, we'll focus on maximum likelihood estimation, which is, as a prerequisite, you would have done maximum likelihood estimation. However, you probably have mostly looked at MLEs or maximum likelihood estimates that are available in closed form, meaning that if you take a likelihood function and if you try to find its maxima, you can solve that and find the exact expression of the maximum. Now, this happens in some situations, but in a lot of situations, we do not have at our disposal tools to at our disposable problems where these estimates are available exactly. So that means some sort of numerical techniques, optimization techniques need to be run in order to find these maximum likelihood estimates, or in general, to solve any maximization problem, okay? And we'll look at MLE estimation and regression, ridge regression and lasso, and so on. We'll also look at expectation maximization algorithm, the EM algorithm. We'll also look at the MM algorithm, which is the majorization minimization algorithm, and a couple of others. Again, similar to before, these are going to be, the approaches here are going to be technical, not very theoretical, but statistical theory for these optimization techniques, and then also their practical implementation. And then finally, we're going to be learning about bootstrap and cross-validation, which is amongst a lot of what we'll do in this third place is also we'll learn a lot of models or methodologies to analyze different types of data, as while we are also learning about maximization, right? Optimization. We'll also learn about various models as examples. Now, within these models, we are going to have to choose between competing models. How do you choose between one model and another model when we are trying to, work with a data set? And so that is something we're going to learn through both Bootstrap and cross-validation. Okay. These 4 sort of rough topics that have been created with the understanding that these are the 4 most common optimization tools that are required in statistics. Computation tools that are required in statistics. So of course, there are lots of vast majority of other computational techniques that are required in machine learning and statistics. But these 4 are roughly your 4 basic ones that if you understand these 4 families, you understand a lot of the computational needs in today's statistical world. We'll also, the specific topics or the highlights of the topics, if you were curious as to what are the actual topics we'll learn. So in the sampling part, in the first part, we'll learn about accept reject samplers. And these are fairly common way of sampling from complicated distributions. For the optimization part, we'll learn about penalized regression. This is the ridge regression, bridge regression, lasso regression, and so on. If you're familiar with these concepts, don't worry if you're not familiar, we'll learn these concepts in the course as well. We'll talk about logistic regression for classification, but through this, a lot of our practice problems or notes will also contain Poisson regression and so on. The one I think really interesting and really fun algorithm we'll learn is the EM algorithm that is used for clustering as well. And it's also used for, in general, censored data. So we'll learn the EM algorithm in general. And another sort of nice new age thing we'll talk about is the stochastic gradient descent algorithm for large data, right? So again, these may not be things in which case this slide is not very helpful for you. But just to let you know that if you are familiar with any of these topics and would like to learn about them, then that's something we'll learn through the course of this semester or through the course of this course. Okay. And lastly, we are going to be focusing a fair amount on R. I'm not assuming that you know all of R very well. We'll start with the very basics a little bit. And then I'm hoping that as you practice more problems, the problems will keep getting a little harder. And so your R skills will evolve step by step while you're going through the problems. Okay. This is the general sort of introduction to the course. I'm going to stop sharing. I'll just talk a little bit about the rough prerequisites that would be required. Certainly, you'll require the fundamental course in probability and statistics, your sort of your first courses that you do. Knowledge of maximum likelihood would be very useful, although I will go a little bit in detail on the likelihood function and maximum likelihood. Understanding different distributions, etc., would be really useful. And if those of you who've had a linear models course this past semester, understanding linear regression, etc., would be really useful just to understand some intuition, not necessary also because we're not going into a lot of details on these topics, but certainly a little bit of understanding will go a long way in for the course. And so that's roughly the prerequisites of what would be useful within the statistical computing course. Now, if there are questions, I'm happy to take some questions. Yes, Varun, please go ahead.
Hi, Dr. Watt. Am I audible to you?
Yes, I can hear you. Thank you, Varun.
Yeah, first of all, I really love the structure of this course. I'm really looking forward to it. I just had one question, I guess, regarding the prerequisites of this course. As I understand, it has to do with Monte Carlo method, maximum likelihood estimation. So you're right, we do need probability, introduction to probability, and I guess some experience in R. But do we really need linear statistical models for this?
No, absolutely not. No, you don't need linear statistical models for this. What you would require a little bit is I will do a little bit of matrix matrix manipulations. However, I will explain them, and they're very much in context to the problem. So even if you don't understand, the whole sort of space of the linear models and the linear algebra associated with it, I will go through the specific tools that you need to understand that particular problem. So no, a rich introduction to linear models is not necessary. Whatever is necessary, I will give you as part of the course.
Got it. Because I have a background in econometrics, so I have done it, I guess, some sort of linear model, but I haven't gone through formally through the linear models course in this program. And I'm not sure if you are the one who set the prerequisite, but for the prerequisite for this course listed as linear models, I'm not sure if that's an error or if that's required. Is that something you're aware of?
I'm not aware of that, but we can have a chat later on with the team to see whether how much of it is absolutely necessary. But a full course on linear models is not something I expect at all. Linear algebra or just some understanding of matrix manipulations is all something that would be hands-on required, but I'll also go through them in the course as well. So maybe we can have a chat with the team and see whether that's a reasonable prerequisite or not. But thanks for pointing that out.
Got it. Perfect. Thank you so much.
Okay, Preetodeep has a question. Do we have any projects for the course? So at this time, we do not have projects for this particular course. In the future, we may think of running the course with projects, but because this is the first time we'll be running the course, currently we're not thinking of, we're not inclined to have projects in the course. So the linear statistical models degree level course is mentioned as a prerequisite. Is that an error then? I don't want to, I'll talk to the team and we can come to a consensus on exactly how much of that course is actually required. I can say that if you have not had the linear statistical models course, then it's likely that you will struggle just a little bit for 1 week of the course. And then, you'll be fine otherwise. So, if there are concepts that I can bring into the course structure that are required, then I might do that. But let me go back and talk to the team and see what we need from the linear statistical models course. Will we have pen and paper based subjective quizzes for this subjects, or will it be MCQs as usual? So we're planning a mix of both. So there will be MCQ questions for sure, but it's not really very practical to have all MCQ questions towards the later part of the course. So we will have a mix of both. We're hoping to have a mix of both subjective and MCQ questions. So both. Okay. Varun, if I could request you to please put your hand down, that would be very useful.
I have one question.
Yes, Mukesh.
Is there will be any OPP, means programming assignment on R? Are you planning any OPP?
Programming assignment on R, yes. So the sort of weekly or bi-weekly sort of sheets that you submit that count for roughly 10% of the course, that will have some components of that will have R assignments in there. Yes.
There will be no exams based on programming, right?
So I will not ask you to program in exams because that was quite challenging. But for example, I might give you a little bit of R code in a question and ask you to use that in your calculations or something like that. Okay. So up till that amount, I'm going to we're going to be okay with putting in the exam. But in the actual quizzes and the exams, you're not going to be asked to code anything.
So is any specific reason you are putting R or not as a Python? Because from the foundation course till now, we are more familiar with the Python. So,
so one of the reasons is that through this course, you will also learn R. And for a lot of the data science and statistics sort of work, R is very popular. So that's one of the reasons. The second reason is that although we're not using a lot of built-in functions. We are not going to be calling a lot of complicated functions that implement the EM algorithm or this algorithm or that algorithm. We are going to be writing codes to implement the functions. So in some sense, the platform that we're using does not matter. You need to be familiar with loops, if, while, and that's about it. And so that's mainly it. And the third reason is that, R is something I deal with day to day. I'm not somebody who deals with Python day to day. And so R is, more popular in the world that I come from. So I'm going to use R.
Okay. That will learn. Thank you. So okay, if it is possible, can you share some tutorials so that we can learn as a prerequisite for the R? Any tutorial
Sure.
which so that will be help to us.
Yeah, so I will say that the first video of the course is an introduction to R.
Thank you.
And it has a sort of a starter file that you can load. I'll share the material. The materials obviously will be shared with you that you can work through and understand. And also, every single video where I'm showing a concept that will be implemented in R, I'm also showing you R videos and R codes for it. So I'm going through the R code, and also there are videos that only have R implementations in them. Okay. So and all of those codes will be shared with you. So it might seem a bit daunting that you have to do all of this in R, but just by looking, because I'm doing it right there with you, you can gauge a lot of what's going on. Regarding the tutorials, there are a couple of different, there's a couple of books and a couple of tutorials that are available online, and I'll let the team know, and that can be shared with everyone.
Yes, thank you.
You're welcome, Mukesh. Are there any other questions? Anything on the live stream? Maybe Shrikant?
No, ma'am. Let me check just a second.
Yeah, Preetudi, please go ahead.
Yeah, good afternoon, ma'am. Am I audible?
Yes, I can hear you.
It's not a question as such, just a point of information. The course page on the website needs to be updated. It's lacking any information regarding the weekly content and whatever we have as part of this course. So just want to let that know.
Okay, sure. We'll note it down and maybe let the team know that that should be updated.
Yeah, and ideally it would be good to have it updated before the registration deadline. So that's just something.
I'll once we're done with the meeting, I'll send over an email that lets them know, and hopefully it'll be done as soon as possible.
Yeah, sure. Thank you, ma'am. Thanks.
Yeah, you're welcome.
Ma'am, nothing related to statistical computing.
Okay.
Yeah.
Okay. Is there anything else, Shrikant, that we should go over?
Maybe Varun, Mukesh, Anant, do you have any queries? You can ask.
So maybe one last query. I mean, I have a query. So I have been out of touch with statistics for the past 3 or 4 terms because I have not had any statistics related courses till now. I mean, last I had statistics was back in the foundational level. So could you maybe you could give us some suggestions for students such as myself who have not, who need to revise on the statistics?
Okay, sure. Yes.
Which questions we need to cover?
Yeah, so certainly I think because we'll be talking about drawing from different distributions, just understanding, the popular well-known distributions a little bit would be useful. So for example, I'll be talking, although you can go over it, while the videos are shared with you. So I'll go over, for example, how to sample from a geometric, a binomial, or a normal, a chi-squared, a gamma, and it would be useful to just understand how they arise, maybe, or, what their PDFs or PMF functions are. So that's one part. Then the second thing that would be a little bit useful once we get into some of these things would be a general understanding of law of large numbers or central limit theorem. I mean, we don't need it in the sense that we're not proving things barring maybe one result, but just an understanding of, okay, what is the central limit theorem, what is law of large numbers, just a little bit of that. And, what is the bias of an estimator? What is the variance of an estimator? Things like this is sort of what we'll talk about. So just a conceptual understanding of some of these things would be useful. I don't think you're going to require anything that's too heavy. I'm trying to think in terms of the statistics or probability. So the basic concepts, if you recall, then anything you need, you can sort of do on while the weeks go on, I think.
Sure. Thanks, ma'am. Thanks for the response.
Welcome. Yeah, Varun, go ahead. Did you have a question, Varun?
Varun, we are unable to hear you.
Oh, yeah. Sure. It says there's an issue with the audio.
Hi, can you hear me now?
Yes, Varun, I can hear you.
Yeah, so Statistical Inference by Kasela and Berger, that's like one of my favorite books on stats. And I'm someone who prefers to read a book and study from a book alongside the course. Is there a book that you would recommend for me to follow along with this course?
Yeah, so it's a little tough because you can imagine, the contents of the course are from all over the place. So it's sort of specifically designed to only cover all the topics in statistical computing. For the first part of the course, I think simulation by Ross is mostly what we'll follow, although there will be concepts that are not covered in that. And then for the other parts of the course, one can take some things from Introduction to Statistical Learning by Tipshirani et al. These are the two books that are going to cover most of what is being discussed. But I'm not, it's very difficult for this course to follow a book chapter by chapter. So I'm just picking topics from these two places.
Got it. So the page you have on, I guess it's MTH 210A that you teach at IITK. Would the resources listed on there be a good place to get us notes and whatnot?
Yeah, sure. Yeah, the resources listed there would be a good place to look at. And I'm happy maybe we can, after that, when the course page can also be updated for this course with some of the resources listed there as well.
Got it. Thank you so much. I look forward to it.
Thank you, Varun. Yeah, Anant, go ahead.
Yeah, good afternoon, ma'am.
Good afternoon.
There's another course, the linear statistical models, which is being offered this term. So would you recommend to do that course first, or is it okay to take this course right directly before that?
So yeah, I guess this is a point of contention. So we should maybe figure it out. So on paper, it certainly seems like it's listed that the linear statistical models is a prerequisite for this course. So the only reason I can think of why that should be a prerequisite is if you're very new to statistical things in general. This particular course might require a little bit of what I call statistical marination, because we're covering a lot of topics and it's a slightly fast-paced sort of structure. So we're jumping from one topic to another topic to another topic. So if you've had more statistical exposure before this course, then I think it might help you to have the maturity that might be required for the course. That is not to say that this course particularly is requires a lot of topics from the linear models course. It does not. Only just a little bit of an introduction to linear regression is sufficient. And I'm going to give that introduction to linear regression in the course as well. So the only reason I can think of maybe why it might be a good idea to take the linear statistical model course first, if you as it is are inclined to take both eventually, would be that particular course is likely following more of a standard book and has a little bit more sort of structured content, where here also we have structured content, but because it's from everywhere and it's a little fast moving, it would be great if the audience has a little bit more statistical maturity in terms of the concepts that they have been exposed to. Having said that, the way that this course will be taught, most of the concepts that you need will be introduced in those videos as well. So you could take this course without having had linear statistical models, I think.
Okay,
it's a long answer.
Yeah, maybe we can take both of them simultaneously. And
I think
that would be good.
Yeah, I think that might work really well, because if you're taking both of them simultaneously, if that's something you can handle, then you'll already have learned some of the concepts that are required very early on in the linear statistical model course, and then they'll be immediately useful around the middle of the program for this course.
Okay, thank you, ma'am.
Yeah, welcome. Okay, anything else? Yeah, Shrikant?
No, I was just about to ask. Prashant Sharma has joined now.
Okay.
Prashant Sharma, do you have any doubts regarding this course?
So actually, when I joined, ma'am was already talking about the prerequisite thing. So that was the main doubt I had. So if the course mentors, if they allow us to take both the course together, then it will be very good, because just I saw like in few WhatsApp group, and there were a lot of excitement towards this particular course of statistical computing. So, and also we saw in the handbook that this course will not be available at least for the next 3 or 4 terms. So it will be good if you allow students to take both the course together. That is the only thing.
Okay. I'll talk to the team and see if that's a possibility. I mean, because this is the first time I'm teaching as part of this program, so I'll get a consensus on what the ideas are, and it should be okay from my part. But it's maybe there's other issues, and so we'll talk to the people back and get to a consensus on what can be done.
Yeah. Okay.
Actually, my problem is that in current handbook, they have removed this linear statistical model in this term. Okay. So who are the student who has learned in the last semester? They only can go if that is a prerequisite. So that is the main problem for us, because we have not learned the linear statistics in the last term. Okay. And if it is a prerequisite, then we cannot take a chance. And as he told, next 4 terms, this course is not there. So this is the problem for us.
Okay. Okay, sure. So I'll give this feedback back, and if there is something I can do to maybe change the course a little bit so that whatever prerequisites are required, we can just do while the course is going on, then I'm happy to do that as well. So let's see. I'll talk to the team, and very soon, hopefully in a day or 2, it will be clarified for everyone.
Thank you, ma'am. Thanks for your.
Yeah, you're welcome. All right. Anyone else?
Yeah. So that's it.
No more questions. Okay, thank you. Thank you, Preetadeep. Thanks, everyone. I look forward to hopefully having all of you in my classroom, so to say. And good luck for the end of this semester, and hope to see you most of you, or if not everyone, next semester, next term.
Thank you, ma'am. Thank you so much.
Bye-bye.